students, in this video we are going to study the spontaneity of reaction. To know how to predict the spontaneity of reaction, before that let us understand what is the meaning of spontaneous reactions. So students, reactions that take place of their own without any external influence or energy, they are called as spontaneous reactions. All natural reactions, they are spontaneous reactions, and for a spontaneous reaction, delta G sign convention should be negative. Means delta G, if its value is negative, then we say that the reaction is spontaneous. To understand how to calculate this delta G, let us take help of Gibbs equation. Now what is Gibbs equation, students? Gibbs equation is delta G is equal to delta H minus T delta S. So let us see the equation. This is the equation which is also called as Gibbs Helmotz equation. Let us understand the terms which are involved in the Gibbs equation. Delta G is the free energy or Gibbs energy change. Delta H is the enthalpy change, delta S is the entropy change, and T is the temperature in Kelvin at which the reaction is carried out. Before understanding how to use this equation to predict the spontaneity, there are certain rules what you have to use that you must know, and the rules are about the sign conventions. Now students, if you have seen the Gibbs equation, we have two terms that we'll be using. The first term is delta H and the second term is T delta S, that is the product of temperature and entropy change. If both the values they are positive, then we add both the values and your answer is with the positive sign. The second condition is if both the values they are negative, then we add both the values and your answer is with the negative sign. Third is if one is positive and the other is negative, then in this first case, if delta H, which is positive, if this value is higher, then we subtract this from this and your answer will be written with the positive sign. Similarly, if this value is greater, means T delta S product is greater than delta H, then we subtract this value from this, but your answer will be with the negative sign. Taking into consideration this help, let us apply those sign conventions of delta H and T delta S here in the equation and find out the spontaneity of the reaction. Now the important factor which is playing the most important role here is temperature. So let us find out how to predict the spontaneity. See the first case, student. The first case what I have used here is the Gibbs equation I will be using, but the first case is if delta H is negative and delta S is also negative. Let us put the sign conventions here. They say this is negative and this is also negative. So if I put this, the signs will be like this. Means when I solve this, the signs will be like this. Now if I increase the temperature, then this value will increase. If this value will increase, then this will get subtracted from this product and your answer will be with the positive sign. So the reaction will be non-spontaneous, because for a reaction to be spontaneous, I want delta G value should be negative, and therefore the reaction will be non-spontaneous at high temperature. But if I decrease the temperature, then the product will decrease. When the product value will decrease, means this will be greater than this, and I will subtract this product from this, so I will get the negative sign here for delta G. So the reaction will be spontaneous at low temperature. So when delta H is negative and delta S is also negative, then the reaction will be spontaneous at low temperature and non-spontaneous at high temperature. Let us see the second condition. The second condition is delta H is positive. So this is positive and this is also positive. So when you open up the brackets, you get something like this. So if you see this, again there is a condition where if this is greater, then this will be subtracted from this and delta G will be with the positive sign. Right students? But this is only possible at low temperature, and at low temperature the reaction will be non-spontaneous. But if this is greater than this, how you can do this, student? You can increase the temperature here and when you increase the temperature, this product will increase. When you increase the temperature, this product increases, means your delta G value will be negative, means the reaction will be spontaneous at high temperature, whereas it will be non-spontaneous at low temperature. This is how you have to predict the spontaneity. Let us see the third condition. The third condition is delta H is positive and delta S is negative. So delta H is positive and this is negative. When you open up the brackets, what you get is positive and positive. So if you increase the temperature or decrease the temperature, the product will remain positive. This is also positive. So the delta G value will always be positive whether you increase or decrease the temperature. So the reaction will be non-spontaneous irrespective of the temperature, means whether you increase or decrease the temperature, the reaction will be non-spontaneous. Let us see the fourth condition. The fourth condition is delta H is negative and delta S is positive. Let us substitute that here. So this will be in this way. When you open up this, it will be negative and negative. So this negative and negative means when you add this, the delta G value will be negative. So the reaction will be spontaneous at all temperatures. So whether you increase the temperature or decrease the temperature, the reaction will remain spontaneous. This is how to predict the spontaneity of the reaction. I hope you have understood the concept of spontaneity based on thermodynamics. If you like the video, please like it, share it with your friends, and don't forget to subscribe to my channel to get such more videos. Thank you, students.